I have with me Frank Eulitz, who's Head of Technology for Siemens Oil and Gas. Frank, I'd like to ask you, what do you think makes good research, and in particular in the context of perhaps academia versus industry?
For me, good research is identifying topics with open questions that are of interest for application to product development, with a link to providing improved customer solutions. So I like journal papers that provide that storyline from A to Z and identify the open aspect, the problem position, and the original idea or approach that is being tackled in this paper, and link it back to, at the end of the day, delivering improved products in power or propulsion industry.
Thank you. It's very interesting that you see it in that way. Of course, it's a massive task for an individual researcher to fulfill that goal. So how, as a sponsor of research, do you try to ensure that link from the fundamentals through to the application is carried through? And in a sense, it's about technology transfer.
Yes. In the end, it's not needed that in a paper or journal publication, the authors of academia spend a lot of time identifying the details of technology download and industrialization. However, understanding the purpose and the later application, and just be able to put it into the context, and when explaining and interpreting the results, linking it back to the application is a key value. I've read a lot of good papers that do this, and I read a lot of papers where I found that the authors were not really clear about the purpose, because sometimes there's topics like boundary layer, laminar turbulent transition, that are done by many research institutions, and sometimes from reading the material, I sometimes ask the question, what is the additional value add, and what is the purpose of the paper in respect to later application, and in respect, of course, also to the work published already.
Mm-hmm. And how, in the context of Siemens again, do you try to ensure that the research that is conducted on your behalf is actually directed towards your ultimate goals? And there's an educational aspect to that, but also in the context of technology transfer, you have to take those ideas and translate them through your own work processes to the final product.
Yes, and we have to distinguish also at what stage of work we are talking about. There's very early TRL1 or even pre-TRL1 work where a lot is, you can call it blue ocean work, where you're looking into or trying in a more explorative manner, where sometimes a lot is coming from the university or from academia with good suggestions of what could work out. And then as work is supported and sponsored, as we increase the TRL level, it gets more and more hooked up into existing roadmaps. And then there's then also increase of more and more work coming from the industrial side, eventually handing over, depending on the topic we are talking about. Yeah.
In terms of technology readiness levels then, I mean, do you see academia sort of fulfilling the roles of maybe 1 through 3 or 4 and then industry taking over, or is there a broad overlap?
It depends. If you think of design tools of computational fluid dynamics, like, for example, the CFD code developed at the German Aerospace Center jointly with MTU, you could argue that this software package is in a TRL7 or industrial stage, while still there is model enhancements being developed, validated, which are at different TRL stage. So here we have a complex picture from early stages where you enhance the method, for example, for conjugate heat transfer, or you apply it already for production-relevant calculation. Also, when you then think of experimental world of rigs, we have simple lab setups that are demarked here L2 or 3 levels, and you have, with a lot of institutions, we have rather realistic, bigger, more complex test facilities that are on the level of TL4 and 5. And corresponding with these experimental or validation work, there's according interaction between the academia and the industry.
Frank Eulitz, thank you very much.